Welcome to this video on significant figures and scientific notation in scientific measurements, presented by Luis Bello. Significant figures, or sig figs, are digits that carry meaning in a measurement. They indicate the precision of a measurement, including all certain digits plus one uncertain digit, which is critical for accurate scientific reporting. The rules for identifying significant figures are straightforward. All non-zero digits are significant, and zeros between non-zero digits are significant. Leading zeros are never significant, but trailing zeros after a decimal point are. For example, 0.00340 has three significant figures. Here are more examples. 1.234 has four significant figures. 1200 has two, while 1200.0 has five because of the trailing zero after the decimal point. Finally, 0.00120 has three significant figures. When adding or subtracting, the result should have the same number of decimal places as the measurement with the fewest decimal places. For instance, 12.34 plus 1.1 equals 13.4, and 3.456 minus 2.1 equals 1.4. For multiplication and division, the result must have the same number of significant figures as the measurement with the fewest significant figures. For example, 2.34 times 1.2 equals 2.8, and 4.56 divided by 2.1 equals 2.2. Scientific notation is a way to express very large or very small numbers. It is written as a times 10 to the power of n, where a is between 1 and 10, and n is an integer. To convert to scientific notation, large numbers like 1234 become 1.234 times 10 to the power of 3. Small numbers like 0.00123 become 1.23 times 10 to the power of negative 3. When moving the decimal point, moving right results in a negative exponent, and moving left results in a positive exponent. Examples include 45,600 equaling 4.56 times 10 to the power of 4, and 0.0078 equaling 7.8 times 10 to the power of negative 3. For multiplication in scientific notation, you multiply the a values and add the exponents. For division, you divide the a values and subtract the exponents. For addition or subtraction in scientific notation, you must first convert the numbers to the same power of 10. For example, to add 3.4 times 10 to the power of 4 and 2.1 times 10 to the power of 3, convert the second term to 0.21 times 10 to the power of 4. Resulting in 3.61 times 10 to the power of 4. Significant figures and scientific notation have common applications in atomic scale measurements, astronomical distances, chemical concentrations, population statistics, and molecular calculations. In laboratory examples, volume measurements like 25.6 milliliters have three significant figures. Mass measurements like 0.0234 grams have three. Temperature readings, such as 98.60 degrees Celsius, have four significant figures. Scientific notation is used to represent real-world constants, like the speed of light at 3.00 times 10 to the power of 8 meters per second, the mass of an electron, and Avogadro's number. For rounding rules, if the next digit is less than 5, round down. If it is exactly 5 or greater than 5, round up. For example, 3.55 rounds up to 3.6. Common mistakes include counting leading zeros, forgetting trailing zeros after a decimal, mixing up rules for different operations, and incorrect rounding. Practice identifying significant figures with these numbers: 0.00340, 1.200, 340,000, and 340,000.0. Now, practice converting to scientific notation: 0.000234, 45,600,000, 0.000089, and 123.4. For combined applications, practice solving complex problems and expressing the answer with the correct significant figures, as shown in this example. In summary, significant figures indicate precision, and scientific notation simplifies very large or small numbers. Both are essential for scientific calculations, so remember the specific rules for different operations, as practice leads to mastery.